Pens are cheap and made by the billion, but behind this seemingly simple tool is some very precise engineering. We CT scanned 3 different styles of pen to see how they work and reflect on the sophisticated manufacturing needed to make these everyday writing utensils. Let's start with an historical pen design, the fountain pen. These have been around since the 10th century, with the first recorded version being commissioned by an Egyptian caliph in 974. More practical designs came about in the 19th century, and the modern fountain pen became widely used following a series of key innovations, such as the iridium-tipped gold nib and a system for handling ink flow internally. Fountain pens store ink in a cartridge or reservoir within their barrel. When the pen is at an angle like this as you write, gravity causes the ink to flow toward the nib. The feed is located just below the nib here, regulating flow and ensuring a steady supply of inks as you write. Capillary action, which draws liquid through a narrow channel even against gravity, pulls ink through the nib's slit, which allows it to flow with minimal pressure. We decided to scan a contemporary version of the classic fountain pen, a Mahjong A1. It has a modern retractable design that protects the nib but maintains the elegance of a traditional fountain pen. In our industrial CT scan of the pen tip, we also find a spring-loaded door that pops open when you extend the nib from the pen and closes back over the nib when you retract it, preventing it from drying out. Now this is one of the most common pen designs in the world. The ballpoint pen was invented in the 1930s and hit the market in the 1940s, but it really became popular in the 1960s when disposable pens were introduced. The key advancement that made ballpoint pens practical was the development of a fast-drying, oil-based paste ink that wouldn't leak from the pen tip or smear on the page. Let's look at a scan of the ballpoint pen. This is a dense tungsten carbide ball that's held in a brass enclosure. Channels for the ink to flow through are visible here, reaching into the inkwell and stopping at a ring below the ball. The tungsten carbide ball is milled to an accuracy of just 100 nanometers. How do all of these very small parts get put together in a factory? The ball is inserted into the housing through the tip. Then the assembly goes into a stamping machine that crimps the brass housing down around the ball. These are some really tight tolerances. Our last pen technology is a more modern development. The Rollerball pen design was introduced in 1963 with a water-based ink to combine the form factor of a ballpoint pen and the smooth, wet ink effect of a fountain pen. There are other advantages and trade-offs with this pen too. It needs less pressure to write smoothly and has a wider range of colors than the ballpoint, though it's more likely to bleed through paper and tends to run out of ink a little faster than ballpoints. These also come in a gelled ink version, which saturates paper more than other inks to give a unique writing quality. The assembly process for these are clear in our CT scans. At the tip of the pen, we see another tungsten carbide ball. It's housed in a stainless steel tube. During the manufacturing process, the ball is dropped down the length of the tube. Then the tube is crimped in from 3 directions to hold the ball against the opening at the end of the housing. Even the most ordinary pens hide a lot of precise engineering to make sure they keep writing to the same standard every day. You can see these scans for yourself. Just follow the link in the description below. And if you want to learn more about industrial X-ray CT technology and how engineers use it to improve everything from running shoes to medical devices, check out this introductory video, or just visit us at lumafield.com.